So this is our lesson video for section 9.4, and so in this video we're going to focus on how to name acids or compounds that normally start with hydrogen in their forming. It depends on what kind of acid. If you move on to like organic chemistry, you'll find that sometimes they don't put the acidic hydrogens in the front of the formula. It just depends. Alright, so an acid is a compound that produces H+ ions when it dissolves in water. The formula for an acid will normally start with H. Water, of course, starts with H, but it is not an acid, it is not a base, it is neutral. When naming acids, you should first determine the suffix of the anion. The suffix is the ending. So chloride has an "ide" ending. Sulfate has an "ate" ending. Nitrite has an "ite" ending. So really we'll be focusing on three endings. Does it end in "ide", does it end in "ate", or does it end in "ite"? So acids containing anions whose names end in "ide" are named by adding the prefix hydro and the suffix "ic". Also add acid at the end. So HCl. Cl is normally called chloride, so we change it to hydrochloric acid. So we just took chloride and put hydro in front and changed the "ide" to "ic". That's all we're doing. Okay, so let's look at a couple. So HF. F is called fluoride, so it becomes hydro, there's my prefix, fluor, instead of "ide", "ic", acid. Okay, so hydrofluoric acid instead of fluoride. All right, HCN. Cn is on your polyatomic ion sheet. It is cyanide, so we change it to hydro, there's my prefix, cyan, instead of cyanide, I'm going to do "ic" acid. So it's hydrocyanic acid. All right, so hopefully you're catching on to the trend there. So when we have "ide", we just add hydro blank "ic" acid. Here, I'll put acid underneath just so you don't forget about acid. So if it ends in "ide", it becomes hydro blank "ic" acid. And the blank is just filled in by whatever that anion is. All right, so here, you try a couple. Okay, so pause it, try it, and now we'll look at them together. So Br is bromide. So this one will become hydrobromic acid. Okay, so instead of bromide, it becomes hydrobromic acid. Hopefully you got that one right. All right, last one is HI. I is iodide, so it becomes hydro, io, instead of iodide, we just take it and change it to "ic". So hydroiodic acid. All right, and that's all we're doing. We just take the anion and we put hydro in front and change that "ide" ending to "ic". That's all you have to do. All right, so that is how you name if it ends in "ide". So let's look at our two other options, because we know that polyatomic ions chart is full of ions that end in "ate" and "ite". All right, so when an acid contains a polyatomic ion, you must determine whether or not it ends in "ate" or "ite". If a polyatomic ion ends in "ate", we change the ending to "ic". So if it ends in "ate", we change that ending to "ic". For example, HNO3. NO3 is on your polyatomic ion sheet. It is nitrate, so we change it to nitric acid. If a polyatomic ion ends in "ite", then we change the ending to us, O-U-S. So ite goes to us. So HNO2, NO2 is on your polyatomic ion sheet. It's nitrite, so it becomes nitrous acid. So notice on these, there is no hydro in the front, even though they still start with H. That throws people off when you're naming because you see the H, so you want the name to somehow indicate there's an H. Well, I always say use acid to make you think of H. So if something has acid in the name, it's going to start with H. In how we write it in here. So let's look at a couple together. So we have H2SO4. So SO4 is on your polyatomic ion sheet. It's sulfate. So that's an 8 ending, so I'm going to change it to "ic". Now a lot of you, you're going to think it's going to become sulfic acid, but it actually becomes sulfuric acid. And it's okay if that's a little confusing in the beginning. For sulfur and phosphor compounds, we add the extra syllable to the name. So like phosphate and phosphic also get an extra syllable. But if you wrote sulfic acid for this, I would mark it right because you're showing me you know how to use the rules. And then as we get further into the class, you'll realize that sulfic acid doesn't make any sense. All right, and so notice I don't have hydro because it did not end in ide. All right, so next one, H3PO4. So PO4 is phosphate. Okay, so because it ends in 8, I'm going to change it to ic. But it's not phosphic acid, it's phosphoric acid. But again, if you wrote phosphic acid, I would mark that right because you're showing me you know how to use the rules. I can't guarantee it though if you're not in my class. Your teacher may be super picky. I can pick you later, but in this part, I just want you to know the rules. All right, and so now we have H2SO3. So SO3 is on your polyatomic ion sheet. It is sulfite. So ite turns into us. So it becomes sulfurous acid. So like I said, for sulfur and phosphorus polyatomic ions, we just add the extra syllable to it to make the name for it. All right, so let's erase and see if you can try some on your own. All right, so pause it and try these real quick and then we'll look at your answers. All right, so our first one, H2CO3. CO3 is carbonate. So 8, of course, goes to ic. So it becomes carbonic acid. All right, remember, no hydro unless it ends in I. So hopefully you got that one right. All right, let's look at our next one. We have H3PO3. So PO3 is phosphite on your polyatomic ion sheet. So ite goes to us. So remember I told you about phosphorus. It has that extra syllable. So it becomes phosphorus acid. Phosphorus. However, if you wrote phosphorus acid, I would mark that right while we're still learning. All right, and then last one. Hopefully you got that one right, even if you forgot that extra syllable. Our last one is HClO2. ClO2 is chlorite. So it has an ite ending, which becomes us. So it becomes chlorous acid. All right, so see, it's not that bad. I becomes hydroblankic acid. 8 goes to ic, and ite goes to us, and neither of those have hydro in the front. All right, so now let's look at, well, what if we need to write the formula? So when you write the formula, for an acid, always start with H, even if the name doesn't say it. So remember, only some of them are going to start with hydro, but they all start with H. So when you see acid, you need to go ahead and put H. Don't forget, you've got to cross or balance your charges. And then just remember, if it ended in ic, you find the 8 ending on your polyatomic ion sheet, and if it ends in us, you find the ite ending on the polyatomic ion sheet. So make sure you have a polyatomic ion sheet out. That kind of helps. All right, so it says write the formula for the following acids. So we have hydrosulfuric acid. So if it ends in acid, it starts with H. H is in group 1, so I know it's a positive 1 charge. Hydrosulfuric means it came from sulfide. Sulfide is just sulfur with an ide ending, just like oxide is oxygen. Sulfur is in group 16, so it has a -2 charge. And so then I just cross my 2 down. So it's H2S. All right, next one is hypo, oh, there's typo, but it's not hypo. Hypo is not the typo. It's chlorous. Should have an L there. All right, so it's not hydrochlorous, it's hypochlorous acid. So if it ends in acid, it starts with H, which has a positive charge. Hypochlorous came from hypochlorite. If you look at your polyatomic ion sheet, hypochlorite is ClO -1. So since I have a positive and a negative, they cancel, so I don't need to cross anything. All right, last one is acetic acid. It ends in acid, so it starts with H. Acetic came from acetate. So if you look at your polyatomic ion sheet, acetate is C2H3O2 -1. So since I have a positive and a negative, they cancel, and so I'll leave it like this. Now some of you want to know, well, why can't you just put this H here and do 4 H's? Technically you can, but we like to keep our acidic hydrogens in front, whereas these hydrogens are not acidic hydrogens, which means they're not going to break off when you dissolve it in water. All right, so let's see if you can try some of these on your own. Oh, I forgot my L. All right, so here, you try these 3, and then we'll check your answers. So pause it, try it, and I'm going to assume you've done that at this point. All right, so perchloric acid, if it ends in acid, it starts with H, which has a positive charge because it's in group 1. Perchloric came from perchlorate. If you look at your polyatomic ion sheet, perchlorate is ClO4, -1, +1 and -1 cancel, so I don't need to cross my charges. Hopefully you got that right. Next one is chromic acid. If it ends in acid, it starts with H, which has a positive charge. Chromic came from chromate, which is CrO4, -2. I have a +1 and a -2, so I need to cross my 2 down. So my answer would look like this. And remember, you're more than welcome to keep the charges or not. All right, last one is oxalic acid. So it ends in acid, so it starts with H, which has a positive charge. Oxalic came from oxalate. If you look at your polyatomic ion sheet, oxalate is C2O4, -2. So I have +1 and -2, so I'm going to cross my 2 down. So I get H2C2O4. All right, so hopefully you at least got a couple of those, right? It's just crossing charges. They just all happen to start with H. So remember, when you see acid at the end of a name, you need to go ahead and start the formula with an H with a +1. All right, so we've talked about acids, so now we're briefly going to talk about bases. We're not going to talk about them a long time because you already know how to name them. A base is a compound that produces hydroxide or OH- ions in water. When you name a base, you just name it like any other compound that starts with a regular or a transition metal. So see, since we already learned that in section 1 and 2, there's no point in going back over it again. So for example, NaOH. Na is a regular metal, so we just name the metal, sodium, name the polyatomic ion, hydroxide. That's all you have to do. When writing the formula for a base, you still need to balance your charges. So magnesium hydroxide, magnesium is Mg. It's in group 2, so it has a +2 charge. Hydroxide is on your polyatomic ion sheet. It's OH with a -1, but you gotta be careful. Remember what I told you about hydroxide. That's the most common one y'all forget to put parentheses around. Because see, I need to cross this 2 down. Even though it doesn't already have its own subscript, it's still a polyatomic ion. So don't forget to put parentheses on that hydroxide if you need to add a subscript. That's a common mistake. Even some of my AP students make that mistake. All right, so let's knock out our section assessment. So how are formulas for acids determined? Well, the formula for an acid will start with hydrogen. It will start with hydrogen. Number 2, how are bases named? Well, you just name the metal, and then it's going to end in hydroxide. So you can say you follow the regular or transition metal rules. Number 3, give the name of HNNO4. All right, so it starts with hydrogen, so I know it's going to be an acid. So I say, okay, well, what is NNO4? Well, if you look at your polyatomic ion sheet, MnO4 is permanganate. All right, MnO4 is permanganate. So when I name an acid, 8 turns into ic. So it is permanganic acid. And that's it. And yes, is permanganic acid something weird for you to say? You probably don't discuss that with your friends on the weekends. Yes, but as you get used to seeing it, it's not quite as weird. All right, so number 4 says, give the names of these bases. So this is where we got to be careful. All right, so we have LiOH. Lithium is a regular metal. I'm just going to put Rm. That means I don't need prefixes. I don't need Roman numerals. So I just name the first element, so it's lithium. And then I name my polyatomic ion, hydroxide. Okay, so let's look at part B. Lead can have multiple charges, so it falls in our transition metal category, even though it's under the stair step. So that means I'm going to need a Roman numeral on this one. So that's where you have to be careful for bases. Some of them need a Roman numeral, some of them do not. So PB, I just name it, it's lead. I'm going to save room for that Roman numeral, and then OH is hydroxide. That's from my polyatomic ion sheet. Alright, so I have to figure out what charge lead has in this point. So hydroxide is -1. So that means this has a -1 charge, but I have two of them. So that's -2. So to cancel out a -2, lead has to have a +2. Once I determine that, I can put my Roman numeral 2 there. Alright, so part C, aluminum is a regular metal. Remember, it's the one regular metal that's past the transition metals and under the stair step. So that means I don't need any Roman numerals, don't need any prefixes. So Al is aluminum, and OH is hydroxide. So see, all our bases are just going to be something hydroxide, something hydroxide, something hydroxide. It just depends, is it a regular metal or does it need a Roman numeral, is it a transition metal? Alright, so number 5 says identify each compound as an acid or a base. So acids release H+, so H is going to be at the beginning. Bases release OH negative, so OH would be at the end. So BaOH2, because it contains hydroxide, is going to be a base. HClO4, because the hydrogen is listed first, it has a positive charge, so H positive means it is an acid. And KOH, because it ends in the hydroxide ion, is a base. Alright, so let's move on. I think there's a couple more questions on the next slide. Alright, so it says write the formula for the following compounds. So we have carbonic acid. Remember, if it ends in acid, it starts with H. H has a positive charge. Alright, so we have H+. Carbonic came from carbonate. So if you look at your polyatomic ion sheet, carbonate is CO3, -2. And so a +1 and a -2 don't cancel, so I cross my 2 down. So it becomes H2CO3, carbonic acid. Alright, part B, sulfurous acid. Remember, if it ends in acid, it starts with H, which has a positive charge. Sulfurous came from sulfite. So when you look at your polyatomic ion sheet, it will tell you sulfite is SO3 -2. So I again need to cross my 2 down. Alright, and last one, this one's a base because it ends in hydroxide. So it's iron 3 hydroxide. So iron is Fe. The 3 indicates the charge, not the subscript. Hydroxide is on your polyatomic ion sheet, is OH with a -1 charge. So I need to cross my 3 down, but even though hydroxide does not have a subscript, it is still a polyatomic ion. So I still need to put it in parentheses. Alright, so as much as a lot of y'all do not enjoy nomenclature, which is just naming of compounds, I personally love it. Of course, it's one of my favorite things, just like everything in chemistry. But it's just super important because as we move on into chemical reactions, we're going to use naming. And so if I say iron 3 hydroxide reacts with something and you can't write the formula, you're going to start struggling more and more and more. Chemistry is a class that builds. Okay, so make sure that each time you move on from a chapter, you really understand the previous chapter and the previous content. And if you're not, then either watch the videos over again. I have tutorial videos, which are separate from these on my school website, or come to me for tutoring. Any of those things work. All right, but either way, you've got to get the naming down. That is an important skill to have in chemistry. So good luck.